In this video, we'll be talking about student loans and in particular the amortization of those loans. The amortization is a way of saying how the loan decreases, or what we're interested in, what is the monthly payment. So this formula, m equals p times this large quantity I over 1 minus 1 plus I to all to the negative n. Well, let's look at what each of these means. The m, that's your monthly payment. And you might be aware that student loans are compounded, or you're charged interest daily. But let's just look at this monthly, because that's usually what your payments are monthly payments. The P then, P is your principal. So how much is your initial amount that you will have to pay back over usually 10 years. Usually student loans are amortized over 10 years. And then I, this I is unique. This I is the monthly interest rate. Monthly, the monthly rate. So I know you always are given the annual rate. So the monthly rate is the annual, or APR, so the annual rate divided by 12, because 12 months. So that's how you get the I, the annual rate divided by 12, and it'll be in as a decimal. N here is the number of payments. So it's the number of months. Number of payments, or if you're paying monthly, number of months. Okay, and then you can just throw everything in there. So let's say you have an initial principal. You end of school and you have your initial principal of $14,000. Well, let's plug in what we have. Let's say we have P equals $14,000. And let's say your interest rate, let's make that capital I, that's annual. The annual interest rate is, let's say, 6%. Okay, at 6%, then the little I, that's your monthly rate, I would be 0.06, right? This has a decimal, divided by 12. And that equals 0.005. So that's our little I. N, we said that's going to be 120 months over 10 years. So 12 times 10, 120 months. So we just plug everything in there. All right, let's do that. M is what we don't know. That's our monthly payment. P is our principal. So that's $14,000 times I, 0.005, all over 1 minus the quantity 1 plus 0.005, raised to the negative exponent, negative 120. That accounts for the decreasing factor because the amount is taken off every month. I won't slow you down with order of operations and show step by step, but you do exponents first, right? 1.005 raised to the negative 120, and then 1 minus all of that, and then 1.005 divided by all of that, and then at the end multiply that by 14,000. And you get $155.43 every single month for the next 10 years. Okay? How much does that come to total? Well, it's going to be actually more than the initial 14,000 because you're renting this money. So what you have to do is you can say that that total amount that you've paid equals the 155, or this M, multiplied by the 120, and you get $18,651.60. So that is the amount, the total amount that you pay back. And you're thinking, hey, that's more. Yeah, you're renting the money, and so that's then the total interest that you've paid over that time is the difference between the 14,000 and the 18,651. So that's an interest of $4,651.60. So that is the loan amortization of a student loan example.